let's talk about exponential equations. So in this video lecture, our objective, we want to solve exponential equations. But I want to note here that this methodology will not solve all exponential equations. What we're going to talk about here is how to solve exponential equations that can be solved by applying the laws of exponents. They all cannot be solved by doing this, but some can. And so we're going to take a look at those and the algebra involved. So, what do we know? Well, we know the laws of exponents. Now, I'm not going to write them all down. In a previous video lecture, I went over them, and here we have them. The key ones we want to note, a negative exponent means the reciprocal. When you have the same base and you multiply, you add the exponents. When you have the same base and you divide, you subtract the exponents. An exponent raised to a power, a base raised to a power, you multiply the exponents. We also want to take a look at this one here, that a division problem raised to an exponent is the same as the numerator raised to the exponent divided by the denominator raised to the exponent. And this is the same one as you see up here. X to the negative n is the reciprocal. It's 1 over x to the n. So those are a couple of things we want to note, but we've been through those. And you need to have a good sense of those as you work through these problems. All right, we want to add to that one additional small thing that if you look at it, makes a lot of sense. If a base raised to an exponent equals the same base raised to an exponent, then the two exponents are equal. If x to the 2 equals x to the 2, then 2 equals 2. Okay? So if you have the same base on both sides of an equal sign, then their exponents are equal. In other words, when two exponential expressions, 1, 2, with the same base, in this case a and a, are equal, their exponents are equal. So, solving, again, some exponential equations can be done by manipulating each side as needed so that the base is the same. You want to have one base and one exponent per side, and you want that base to be the same on either side. So let's do some solving and see how this works. Okay, here's an exponential equation. Exponential because we have a variable in the exponent. 2 raised to the 3x minus 1 is equal to 32. What is x? Well, you need to know a good thing to understand is your exponents in terms of knowing your number exponents kind of off the top of your head, or at least with some sense. 32, this is base 2. Well, 32 can also be written as base 2. So the left side is 2 to the 3x minus 1. Well, 32 happens to be 2 to the 5th. Okay, so you have to have some sense of your exponents and your numbers as well to work with this stuff, depending on how complicated it gets. I happen to know pretty quickly that 32 is 2 to the 5th. So now I have one base on each side, and that base, one base and one exponent on each side, and the bases are equal, so I know the exponents are equal. And so now I have an equation I can solve quickly. I'll add 1 to both sides. I'll divide both sides by 3. And in this case, x is equal to 2. If you put this into your calculator, 3 times 2 is 5. Let's try that again. 3 times 2 is 6. 6 minus 1 is 5. 2 to the 5th is indeed 32. Okay, let's take a look at this one. Example 2. Okay, I have a base of 4 on the left side. The exponent is 2x minus 5. And I have a 1/16 on the right side. I need to manipulate so that I have the same base on both sides. Well, 16 is 4 squared. So I can start manipulating the right side. This is 1 over 4 squared. Okay, well now I've got what I'm looking for there, but this is not going to work because that's not a base, that's a fraction with an exponent in the denominator. Well, we know that I can find the reciprocal of this by putting a negative exponent. So the left side again, 4 to the 2x minus 5. 1 over 4 squared is the same as 4 to the negative 2. Okay, let me go back and show you in the Laws of Exponents where we saw that. We saw that right here. 1 over x cubed in this example is the same as x to the negative third, the reciprocal. So we're just using that fact here to say that 1 over 4 squared is the same as 4 to the negative 2. Now I have one base and one exponent on each side. The bases are equivalent, so the exponents are equivalent. And I can solve this. Let's see, let's add 5 to both sides. 2x is equal to 3. Let's divide both sides by 2. X is equal to 3 halves, and I'll leave the check up to you. Okay, example 3. We'll do a few more examples to get a sense of this, but the idea is always the same. Okay, 5 to the x squared plus 8 is equal to 125 to the 2x. Well, this base of 5 is pretty set, can't do much with that, but 125 happens to equal 5 cubed. So I can rewrite the right side. I can rewrite 125 as 5 cubed, and now I have it looking like this. Now I'm close. The left side has one base and one exponent. The right side has one base but two exponents. We need to continue to get one exponent. Left side, 5 to the x squared plus 8. Right side, a base raised to a power raised to a power. I multiply the powers. So this is 5 to the 6x. Now I have one base on each side, and they're identical. I have one exponent on each side, so my exponents are equivalent. X squared plus 8 is equal to 6x. This is a second degree. It's a quadratic, so I either need to factor or use the quadratic formula or complete the square. But in any case, set it equal to 0. X squared minus 6x plus 8 is equal to 0. Turns out this one is factorable. Minus 4, x minus 4 times x minus 2 is equal to 0. X squared minus 2x minus 4x is minus 6x. Negative 4 times negative 2 is positive 8. So x minus 4 equals 0, or x minus 2 equals 0. So in this case, I have two possibilities. I have two answers to this exponential equation. X can be 4 or x can be 2. And again, I'll leave the check up to you. Over here, a lot going on. The right side has a base of 3. That can't be any simpler, so can I write this with a base of 3? And then I need to recognize I have two bases over here. I need to have one base when all is said and done. So let's write 9 as 3 squared and raise that to the 2x. Well, 27 happens to be 3 cubed and raise that to the x squared. So I rewrote 9 as 3 squared. I rewrote 27 as 3 cubed. All right, I'm getting closer. Again, I need one base and one exponent. Well, this one is 3 squared raised to the 2x is the same as 3 to the 2 times 2x, which is 3 to the 4x. Okay, that's the first part, the first term there. 3 cubed raised to the x squared is 3 to the 3 times x squared, which is 3 to the 3x squared. And again, my right side is all good, 3 to the negative 1. Okay, same base, I'm multiplying, so I can add the exponents to get one base. This is 3 to the 4x, plus 3x squared equals 3 to the negative 1. Okay, one base on each side, and they're identical. One exponent on each side, so the exponents are equivalent. 4x plus 3x squared is equal to negative 1. We have a quadratic, so we'll set it equal to 0. This one's also factorable, or you can use the quadratic formula. This one factors into 3x plus 1 times x plus 1. 3x squared plus 3x plus x is 4x. Positive 1 times positive 1 is 1. So I know either 3x plus 1 equals 0 or x plus 1 equals 0. Well, here x equals negative 1/3, and here x equals negative 1. So again, here in example 4, we have two answers that make this exponential equation true. All right, for my last example, I want to introduce a letter you're probably familiar with from previous math classes, the letter E. Many patterns in nature can be described using the letter E. The letter E, like the number pi, is an irrational number. Okay? So thus, in some cases, E is the base. E becomes the growth factor. Now on your calculator, E is right here. I don't think I'm close. Let me come down here. It's above the division key. It's a blue key. So if you go into here and you, whoops, I'll clear all this out. What am I doing here? Let's clear. There we go. Here it is. If you press your second key and you press the division key, there's E. And you can make use of E as you do mathematics. You can raise to a power, E raised to the first power, for example. Okay? In any case, here is the decimal approximation according to this calculator of the letter E. Most people would say 2.718. It looks like it repeats, but it really doesn't. It's rounded the final digit and it goes off irrationally with no pattern. But E can be a base, and we'll see that in upcoming problems that involve nature. Okay, so we can use E to the base, and let's take a look at one last solve the exponential equation using the base of E. So left side, E to the 2x minus 1 equals right side 1 over e to the 3x times e to the negative x, all raised to the fourth power. My goodness. Well, base E. Left side's about as nice as it gets. E to the 2x minus 1. Right side needs some work in order to get one base E out of all this. I'm going to do it first, but I'm first going to say that I'm going to leave this e to the 3x, 1 over e to the 3x alone, and I'm going to multiply these two exponents. So this is times e to the negative 4x. Okay, well, let's see. This times this means, so I have e to the 2x minus 1. So this is now a numerator. E to the negative 4x divided by e to the 3x. There are other ways to do this. This is the way I'm choosing to do it this time. Well, same base division means you're subtracting the exponents. So left side, again, stays the same. We're not changing that yet. Right side is e to the negative 4x minus 3x. We subtract exponents, we can write it, well, excuse me, when you divide same base, you're subtracting the exponents. Before I set these equal, we can clean this exponent up a little bit. So this becomes e to the 2x minus 1 is equal to e, well, negative 4x minus 3x is negative 7x. Now I'm good. I'm a little happier with this. I could have just left it here, but then I would have had to do this step anyways. one base on each side, and they're the same, one exponent on each side. When that's the case, the exponents are equivalent. So 2x minus 1 equals negative 7x. Okay, let's move my x's over. So negative 1 equals negative 9x. Subtract 2x's from both sides. Divide both sides by negative 9. And I have x is equal to 1/9. Now, just so you get used to your calculator, I recommend taking 1/9 and putting it into this side and seeing if you get the same answer out. You should. I've already checked it. 1/9 is the answer. See if you can use your calculator to come up with those two being the same decimal number as far as your calculator will go. So there you have it, how to solve some exponential equations. Again, the key, you need one base on the left, one base on the right. Those bases need to be the same, and one exponent on the left and right. When that's the case, the exponents are equal, and you can solve that to find the value of the unknown in the exponent.